Okay, we are looking at the second problem on our sample problems. So if we read it, it says the product of two numbers is 640. Their difference is 12. I need to find the two numbers. I don't know what the two numbers are, so I'm going to call the first one x and the second one y. And then I took the first sentence and I wrote an equation out of that. If you're going to use two variables, you need two equations. So the first equation I get from the first sentence, the product of two numbers is 640. What operation is product? Multiplication. So we just multiplied the two numbers together and set it equal to 640. Is that okay so far? My two numbers are x and y. The first sentence says the product of two numbers is 640. So I did x times y equals 640. The second sentence says their difference is 12. Difference, you guys just told me that the operation for difference is what again? Subtraction. So I just need to subtract my two and saying it's 12. Find the numbers. Well, once you have two equations, you should be able to solve this system. How? Well, if you recall solving systems, you could solve by substitution, where you get one variable alone in one equation, and then you plug it into the other one.
I like substitution.
That's what we're going to do here. You really can't do elimination because this one's multiplication and this one's subtraction.
You could add the y to the other side of the ladder.
I can, yes. Let's do that. So if I add y to both sides over here, now I have one variable by itself, which I can take and plug into the other one. So let's do that. So x is equal to 12 plus y, so I'm going to take 12 plus y, and I'm going to plug it in, replace that x with 12 plus y. Do you remember doing this? Well, you're about to see. Yeah, well, yeah, so that x, I'm now going to place 12 plus y in its place. So now I have 12 plus y times y equals 640.
Then that's 2y, and then you subtract the 12. And you divide by 2.
It's not 2y. It's y squared. So that's where our quadratic comes in, right? So on the left, I'm just going to distribute that y. So I'll have 12y plus y squared equals 640. And now you're realizing, oh, okay, this is a quadratic. But now you've reached the point where it could have been a problem that I gave you yesterday. Forget that it's a word problem. Here's a quadratic, and I'm going to tell you to solve it. So you have all the different tools. You could solve this by, well, is this one that could be solved by square rooting? No, because b is not 0, right? You have a y term. So I can't solve by square rooting. We should try to factor this thing. Let's see if we can do it. So if I'm going to factor it, first of all, I want it in standard form. So I'm going to write y squared plus 12y, and then I want it all to equal 0. So let's minus the 640 to the other side. And now, let's see, I'm trying to find factors of negative 640 that add up to be 12. So just start, 64 and 10. Nope, too far apart. 20 and what, 30? Oh, 20 and 32? (20 and 32), who's got to be, who's positive, who's negative? Yeah, 20 is negative. So there we go. There's my factors of negative 640 that add to be a positive 12. I got y minus 20 and y plus 32. So once you have it factored, what do you do? Set them both equal to 0. So y minus 20 equals 0. Y plus 32 equals 0. So one of my answers is 20, the other one is a negative 32. Now, here's where kids get confused all the time. Those are not the two numbers. If I take those two numbers and multiply them together, I don't get 640. I'd get negative 640. If I subtracted those two numbers, I would not get 12. I'd get 52. Yeah.
Why don't you do that way where you like take half of 12 and square it?
Oh, you could have.
Oh, okay.
Yeah. You can solve it. Once you get your equation, you can solve it any way you want. Hi. Thank you. All right. Emma, one for you. And one for a girl in my C block class. I don't know.
What time is that at?
Maybe she must be in MCAS. Okay, so here's my point. These are not the two numbers. These are two different possibilities for y. Ladies, gentlemen, you are very frequently going to get two sets of answers.
Well,
These are two possibilities for just y. You don't have no idea what x is. You haven't solved for x yet. So, here's what I have to do. I have to figure out what x would be if y were 20.
well,
And what if y were negative 32? Then what would x be? So all I have to do is go back, or I can go right here, actually, because I have x already solved by itself. So if y were 20, what would x be? 32. So x is 32 if y is 20. And if y is negative 32, then x is negative 20. X is negative 20 if y equals negative 32. So really, this whole thing is your answer. You have two sets of them. X is 32 if y is negative 20. X is negative 20 if y is negative 32. Depending on the situation, sometimes you can throw an answer away. Like if they said, if they had said the product of two positive numbers, then I could say, all right, well, I can't have a negative, so I'll throw away that answer. They didn't say that here. They said any two numbers. Sometimes you're doing a word problem and it's a real life scenario. So let's say you're trying to figure out, I don't know, how long it took for the soccer ball to hit the ground. Well, that's not going to be a negative number. So if I got a negative answer, I would throw it away. But in this case, there was no specifications. I can have a positive, I can have a negative. So I have two different sets of answers. Does that make sense? Okay. Let's see. Do you want to try number 1 at the bottom that's just like that? Or should I? Okay, go ahead. Try number 1 and the practice problems. That's just like the one we just did. We'll see if you can arrive at the right answer there, using what we just did as a model. Okay, how do we do? We get somewhere? Help me out with the first equation. If it says the product of two numbers is 65.
X times y equals 65.
That's it, right? Product of two numbers, 65. My two numbers are x and y. Their difference is 8. That's it. X minus y equals 8. Find these numbers. So just like I did on the last one, I'm going to solve by substitution. That's what makes the most sense. I would again add y to the other side. Huh?
What about elimination?
That's multiplication and that's subtraction, so you can't really, yeah, it doesn't work out so nicely. So here I have 8 plus y. I'm going to take 8 plus y and I'm going to replace that x with 8 plus y. So now I have 8 plus y times y equals 65. Distribute, we'll get 8y plus y squared equals 65. It's a quadratic. I can't solve by square rooting because it has a y term. Let me try and factor. I'll write it in standard form first. So let's minus the 65 over. Let's see, factors of 65 that add to be 8. Well, 5 certainly goes into 65. What do you know? 13 times. All right. So, wouldn't that be a y plus 13 and a y minus 5? You with me so far? Everybody's all right? Factors of negative 65 that add to be 8. Or 13 and negative 5. Yep.
So you always have to rewrite it in standard form.
Yes. So now I have my factors. I set each factor equal to 0. So one of my answers will be negative 13, right? Because I'm going to subtract 13 from both sides. The other one will be a positive 5. These are not your two numbers. They're both answers for y. This one, again, go back and read it and make sure that they didn't say that the numbers had to be positive or product of two numbers. Nope, they didn't say anything about the numbers had to be positive or anything like that. So I can have both sets of numbers. So, if y is negative 13, what would x be? Negative 5. So x equals negative 5 if x equals negative, or y, sorry, equals negative 13. And if y is 5, then x equals 13 if y equals 5. There's my two possibilities. Yeah, sorry.
Wait, how come the x and y are
So if y is negative 13, doesn't that make x a negative 5? And then if y was 5, 5 and 8 would get me an x of 13. Yep. Yep.
I don't know if it's just for like the problems we do, but it seems like whenever you change, you took the opposite of the other number. So like negative 5 and then positive 13, and then negative 13 and positive.
For these style problems, that's how it'll work. Yep. Again, guys, don't do all this work and then not check your answer. If this is the case, is negative 5 and negative 13, if I multiply them together, do I get a positive 65? Wow, that's a good sign. Positive 13 times positive 5 is positive 65 also. And then, it's helpful too if you subtract the two. If I do x minus y, so negative 5 minus negative 13 really turns into a plus. Is negative 5 plus 13 really positive 8? Yes. And then it's not a bad idea to check the other one too. Is 13 minus 5 really 8? Yes, I know that I have this right. And I know that both sets work. Okay. Ready to try a geometry problem? Okay, we'll stick with numbers, one more problem. Then we'll try geometry. I actually want to do on the practice problems. I was looking at number 3 as a great question. Let's look at number 3 together. And the practice problems. If we raise a number to the third power, we get 4 times the number. Find all the numbers with this property. Ooh. So, I only have one number this time, right? So I'll just say let x equal a number. If we raise a number to the third power, so what's that look like in math? X to the third, we get equals 4 times that number. What's that look like in math? 4x. I want to find every number that fits that. Where if I take the number and I cube it, I get 4 times the number. Miss Sabia, this isn't even a quadratic. There's a to the third. I don't know what the heck to do with this. You actually do. You just don't know you do. So first thing I want to do, let's pretend it was a quadratic. I couldn't solve it by square rooting, but I would always try to factor. So let's set the whole thing equal to 0 and see if we can get something going there. So if I minus 4x to both sides. Oh dear. Do you notice anything that you can do here?
Take out an x.
Yeah, let's take out an x. Do you notice anything else you can do here? You're right. No, well, you can't square root this side. I don't know if that's what you meant. But this hopefully is jumping out at you, and you're like, oh yeah. And no. X plus 2, x minus 2, because that's the difference of two perfect squares, right? Right? X squared minus 4, difference of two perfect squares. So that can split up. So this x is just going to stay out in the front, and then that x squared minus 4 will split up. X plus 2, x minus 2. Guess what? You have just factored this thing completely. I don't care that it was an x to the third. It doesn't matter. It works the same way. I have factored it completely. Once you have factored something completely, what do? You set each factor equal to 0. It just so happens that x equals 0 is one of my answers. Doesn't 0 hold that property? If you take 0 and you cube it, what do you get? 0. And then that the same thing as 4 times 0? Yeah. So 0 is one of my answers. So I write x equals 0, I write x plus 2 equals 0, and I write x minus 2 equals 0. So I'm going to get 3 answers this time, that's all. Just 0 is one of them. The other one that I get from this is negative 2, and that one will give me positive 2. Wow. Thanks. You can put it right in there. So we already checked 0. Let's check negative 2. What's negative 2 to the third power? So that's negative 2 times negative 2 times negative 2. Negative 8. And is that equal to 4 times negative 2? Fancy. Does positive 2 have that same characteristic? 2 to the third is 8, and 4 times 2 is 8. Oh my gosh. Isn't that nice? How cool. So, there you have it.